Hi everyone, welcome back to another update devlog for Kwyll. It's been about a week since the last one. Much of my time this week on Kwyll has been spent working with the people using the early alpha. Lots of bug fixes and lots of help to try and get them unstuck when they discover problems with the tool. Hopefully being able to turn around fairly quickly and keep them moving. I have got a couple of changes that I'd like to show very quickly, very small changes but interesting ones nonetheless, and one perhaps larger change, but it's work in progress. It's not something that's fully operational yet, but I'd like to show very quickly a preview of what it's going to do and how it might improve the way that logic in particular is created in Kwyll. It's come from the fact that some of the graphs that the testers are creating are actually getting quite large and unwieldy. So I always had this idea, this particular feature in the back of my mind to do. The way that they're testing it has actually just accelerated it along the timeline a little bit, so brought it up a little bit earlier. So I'll go into a bit of detail about what that does. And then just to finish up today, I'd like to showcase some of the work that the testers have been creating on the early testing program with their permission. So if you want to see some of the things that other people can do with Kwyll other than just me, stick around to the end, and I'll share a few small videos from the people testing on the Discord with their permission, as I say. So without further ado, just switch quickly to the editor so I can go through some of the new features. So the first one is, let me just create an object so we've got some logic. Both of these are around logic. So if I go to logic for this object, this one is particularly around variables. So if I create a couple of variables, so we've got something to work with. Now before, once you're in this editor and you wanted to start accessing some of those variables, either to read or write the values from them, you'd have to create get and set nodes. So you create one just by right clicking, select it from the right place in the menu, drop it and choose which variable you want to access. Similarly for set, they're in math at the moment, they'll probably move, but for now that's where they are. And again, you choose which variable from the list of variables that have been defined. Fairly straightforward, but if you're doing it a lot, it can be quite time consuming. So one of the testers came up with the idea of, instead of having to go through 1, 2, 3, 4 clicks potentially to get a getter, it would be handy just to be able to drag and drop from over there. So that's what I did. So now you can just drag and drop. If I drag a var2, it'll automatically be populated, so it becomes a single step operation. Much simpler, much more straightforward. And if you hold shift when you start dragging, it creates a set. So you've got both of them there, and they both work. I didn't hold shift then. If I hold shift now, then we get the set. So that just makes working with variables in the logic editor a lot simpler, more streamlined, hopefully a little bit faster. So that's that one. What looks like a very simple or relatively simple feature on the surface actually proved to be a bit of a problem and was the cause of many of the bugs that I introduced and had to then go back and fix for the people working with the early alpha. But it's a useful thing to have in there, the ability to drag nodes in from other parts of the scene. It will be used for things like when you're doing room logic, dragging objects into the logic to be able to reference objects and so on. So having that ability to drag and drop nodes from elsewhere in the interface is useful to have, but just took a little bit longer than expected. So the only other thing that's been added as a new feature is a new, very simple node transport object. So this is very similar to the, if we go to here, move object. The difference being transport doesn't have the collision features. So where move object will internally move to where you're asking it to move, but you connect these values or set the values to what you want them to be, and it'll move from where it currently is to the target position and report if it collided with any other objects on the way. And you can then connect this and the reference of the object that was collided. Now, that's the most common way of moving things around, but sometimes you'll want to move directly to a specific position on the map or in a room without consideration for what's between where you currently are and what's there. You just want to literally transport from A to B without any collision being considered. And that's what transport object does. It considers neither object collision nor background collision. It will just move you directly to that new position. Very useful for moving into different room types and moving to a different location within that room. So for example, you had an exterior scene with a house, and you had some logic on the door. When you collided with the door, it moved you to a different room on the map and then moved you to the right place within the room. It could do that very quickly and very cheaply without getting caught up in any collision issues. You'll also notice here that the transport object has a ref input, so it can be applied to other object types while the move object doesn't. That's just a deficiency of the move object one at this point. I have got a task to add the ref to the move object so this node can be used to move other objects if you have references to them. So that's that, and those are the only two real features that have been added properly. The other thing I mentioned that I wanted to just quickly demonstrate a little bit about how it's going to work is the concept of subgraphs, and I'll show you quickly why I've put them in. So if I open up one of the test games that has some significant logic in it, so I think this is the overhead view style. And if we go to the player object, for example, it has some fairly complex graphs in there. Relatively straightforward to follow once you get used to it, but can easily get very messy. So one of the things I always wanted to be able to do was to be able to wrap some of these sets of subsets of graphs here. So this, for example, here is dealing with shooting. This entire section of the graph here is all about shooting. So I wanted to be able to wrap that into a single node that you can edit as a separate graph in isolation, and then in the main graph just have it represented by a single node, so keeping things a little bit tidier. It has a number of advantages working in that way, and most node programming systems that I've come across have an equivalent of that. The main advantage, as I say, is that it keeps things a little bit tidier and easier to follow. If you have a single node that just says do shooting and takes some inputs and provides some outputs, it's a lot easier than having to work out what this sequence of nodes actually does. The second advantage is that going forward, I'd like to, once this feature is fully implemented and properly implemented, is to be able to provide pre-packaged subgraphs. I'm calling them subgraphs for the moment. Pre-packaged subgraphs that expose a bunch of inputs and a bunch of outputs potentially, and then you can just drop that subgraph node from a library straight into your logic. So for example, we could wrap up a platformer controller type behavior into a subgraph, provided as part of a library, and then anyone would be able to just drop the platformer controller in and use that facility without having to think about how to implement it themselves. It means that people who have less programming experience or knowledge will hopefully still be able to make things with Kwyll as we build that library of reusable components. But it's a better way of approaching it than actually creating one single custom hard-coded node to do platformer controller myself as a built-in part of the toolkit, because while there may be a whole group of people who don't care how it works, it's just a black box to them and they just drop it in and they get player controller, there will be another group of people who maybe aren't as experienced as the more expert programmers who could create the platform controller themselves, but are interested in how it works. And by having a subgraph facility where you can look into what the black box does and how it's implemented, you can actually go in, not only understand it, maybe tweak it and modify it to suit your needs. So I'll quickly show how that looks from a user interface perspective. It's not implemented in terms of actual functionality yet, so I can't demonstrate it executing, but from a user interface perspective, it works through this new subset of nodes. Some of these will remain, some of them will go, but as I refine the user interface, but basically it all boils around this subgraph node, which has, as you can see by default, it just has a single flow in and a flow out, and it has no ports, but it has got this new button here. So when you click on this button, what you're basically doing is you're diving into the contents of that node, and you can see there's a button here to be able to come back up again. So you're basically diving in and then going back up, and it does support nesting, so we could have a subgraph within this subgraph and so on, and go up and down multiple times. So once you're in here, what you typically do is create inputs and outputs. Now what these do is they're named values, so this could be in 1 and out 1, not particularly imaginative, but serve the purpose of the demonstration. Now these will allow you to plug values into this subgraph from outside. So if we go back up again now, you'll see the subgraph node has automatically placed an input and an output port, which we can connect things to. So if I create an int const, for example, I can connect that to that port. And then when you go in here, this node will get the value that the external, the parent graph is passing in. And similarly for output, the output node will output whatever comes in here, and it'll appear at this port for use further down the chain, further down the main graph. So a quick example, if I just do a math, in fact I'll create another input, so we've got a couple of inputs, and we'll call this one in2, and we just do an add. So this is just a very simple adder subgraph, not really particularly useful. Now we must make sure that for everything to work, there must be a flow through the subgraph. And this works by using a flow in and a flow out node. So I can connect that to here, and then the flow out node, I connect out to that. And this ensures that when this subgraph is connected into, for example, an always, the flow will go into the subgraph, through the flow in, through any nodes that it flows through within the subgraph, and then flow back out of here. So if we had another variable, another node over here, the flow would continue in the parent graph appropriately. So we could maybe set a variable up here, test. I'll create another integer constant just to make sure that we're fully connected. So this is going to be 3 plus 5, and the output we can then put into our test variable. So that's basically just wrapping up this functionality, which is very simple and almost pointless in this particular example, but you can see how we could have much more complex behavior within this graph, this subgraph, and it's just wrapped up into a single node here. So this could be something like platformer controller, which takes the inputs from the input controller and maybe an output of state or the current position after moving or collision, various different things. You can have as many outputs as you like, so I could add another output quite easily in here, and have I don't know, maybe another math which takes those two, and instead of adding them, subtracts them. Now it's important to make sure that this is part of the flow, so we take this out, I'll put that in there. So this will now just take the two inputs in 1 and in 2, it'll add them and send the output to out 1, and then it'll subtract them and send the output to out 2. And again, when you come back to here, you've got this additional output which you can use for whatever you want. So that's the status as it at the moment. One of the things I do plan to change is, because my current design for this, a subgraph node only has a single input flow and an output flow. There's no conditionals or anything like that involved. And it's important that each subgraph has a flow in and a flow out. I'm probably going to make them a default configuration. So when you create a new subgraph and you go into it for the first time, the flow in and the flow out will already be there. You can't delete them, and I will remove them from this list, so you can't add more, because adding more flow in and flow outs will just confuse things. So that's the next the next thing I'm going to do, is just to make it a little bit safer by fixing the flow in and flow out when you're in a subgraph. Otherwise, welcome any feedback on that, thoughts on how you think it might work, any ideas on improving the user interface. I was very conscious of not fixing the number of inputs and outputs in here, but leave it to the subgraph itself, so you can add new ones. I can add another input, and this level automatically adapts, rather than explicitly defining in 1, in 2 and in 3 in somewhere else, like a number of other systems do. I feel that's a little bit more flexible and a little bit easier to manage. Welcome any comments and thoughts on that. So that's that. I think that's pretty much it for the devlog update. As I say, most of the other time this week has been spent working on bug fixes, mostly ones that I've introduced while working on this and the drag and drop, but trying to keep the people working with it in the Discord subscriber channel moving where possible, and trying not to block them as much as I can. And as I say, they're doing some amazing things with it, and have been very kind to allow me to show some of those videos and screenshots, so that you can see what other people can do, and it's not just me that can create things with it, that it is actually moving in the direction of being a usable tool. It's not there yet, but it's getting there, and some of the fun things they've been creating with it. So I'll leave you with that now. Don't forget to subscribe and hit the like button if you like what you see, and I'll leave you with the content from the people on the Discord, and I'll see you next time.